Morning, my name is IQMAL. I'm from group number 2 and I will start the presentation with the introduction. Okay, the car that our group chose is Proton Perdana, second generation. Proton Perdana is a 2.4cc and use K2402 type of engine. The K2402 is a 4-stroke engine which has 4 cylinders, double overhead camshaft design, and use fuel injection as fueling system. The reason that our group chose this car is because Proton Perdana is a Proton's flagship model, and the other reason is K2402 is a Honda K-series engine. It is different with the other Proton car that use Proton Campro engine. Okay, this is the part of the engine. So you can see the piston, the connecting rod, the race pin, and the crankshaft. Okay, I will continue the maximum pressure analysis, which is peak pressure. The peak pressure that we find is using Microsoft Excel combustion analysis sample program. Peak pressure is important to be known because the higher the pressure in the cylinder, the higher the force on the crankshaft, thus the output torque produced become higher. As you can see from the figure, we made a slightly changes that follows our car model specifications, such as the compression ratio, which is 10.5, the bore, which is 8.7 cm, and the stroke, which is 9.9 cm. And displacement, we use displacement formula, which is pi d squared L over 4000. We input the value and we get the displacement, which is 588.5 cm3. This is the PV graph for the Proton Perdana. As we can see from the detailed value over here, the peak pressure value is 78.2678 atm, rounding off to 4 decimal point. That's all from me. Thank you.
Good evening to our lecturer and my friends. I would like to continue my part of the project proposal, which is to calculate the maximum torque. Torque can be regarded as a turning force applied on an object. So to calculate the maximum torque of our Proton Perdana is force multiplied times crank arm radius. So the crank arm radius is piston stroke divided by 2. In our case, we get 49.5 millimeter. Then the cylinder pressure we can get from the previous maximum pressure analysis, which is 793,048.48 Pascal. Then the cylinder bore from the manufacturer's manual is 87 millimeter. So first, the step to calculate the maximum torque is we must calculate the area of piston, which is pi times the bore square divided by 4. We will get the area of piston. Then second, we will have to calculate the force, that is maximum pressure in the cylinder multiplied by area of piston. Just now we will get 4714.4353 Newton. After we get the force, we multiply it by the crank arm radius, which is converted into meter. We will get the torque in Newton meter, which is maximum torque 233.36. Moving on to the next part, maximum power. Power is the work done in time or is in the rate of doing work. To calculate maximum power of our Proton Perdana, the formula is pi times RPM times torque divided by 30 times 1000. So the RPM we will assume it 6500 because according to the Proton Perdana's manufacturer's website, to reach the maximum power, the RPM can go up from 6300 to 6500 RPM. So calculating the power in kilowatts, we get the maximum power of 155.88 kilowatt. Okay, the next part of our proposal is the kinematic analysis of the internal combustion engine of piston Proton Perdana. Okay, the automotive industry deals with the reciprocating engines in which the piston has a linear motion with the cylinder. This kind of movement, the piston's velocity goes to 0 at the TDC and BDC position. In this part, we are going to analyze the kinematics of the piston and determine the mathematical equations of the position, velocity, and acceleration function of crankshaft angle. Okay, you can see in the figure we provided at the right side, the crank radius in this figure A and the connecting rod length in this figure R are always constant, and the distance between the piston pin and crankshaft center X being variable function of the crankshaft angle. Okay. So before calculating the position, velocity, and acceleration formula, we need to find out the components. So the components are the connecting rod length, which we got from the manufacturer's manual, 152 millimeter, and the crank radius from our previous calculation. Then to calculate frequency is RPM, 6500 divided by 60, we get the RP revolution per second. Then 1 divided by the revolution per second, we will get the frequency 0.009231. Then with that, we can calculate the angular velocity, which is 2 pi times frequency, and we got 0.057999 radian per second. So using these components, we can plot the graph for position, velocity, and acceleration. That is all from my part. Thank you very much.
Hello, good afternoon and good day to everyone. My name is Sharvindiran GOPALKRISHNAN and my meeting number is MH19054. Today I'm going to explain about position, velocity and acceleration in the piston of our modern Proton Perdana. Okay, next we'll see the piston position. The distance between the piston TDC and its current position in the bore is called piston position. Knowing the slope of the engine and the length of the connecting rod and the angle of the crank can be used to calculate the position of the piston from top to center. This is the formula for calculating the piston position, where the L is the connecting rod length, R is stand for crank radius, and W stand for 2 pi frequency, and T for degree. Okay, we got this is the graph we got. Okay, the graph we calculate using the formula with the interval of 5 degree. Okay. So from this graph, we got the maximum piston position of 0.201500 m meter at 325 degree and minimum piston position of 0.102557 meter at 595 degree. So we calculate the we calculate the values from the formula and use the Excel for the graph to form the graph. Okay, next we see the piston velocity. The engine manufacturer have a long measure the engine's main piston speed to identify the potential power failure and dangerous RPM limits. So for this, we use this formula to calculate the piston velocity. Same, but a little bit different. Where the R also stands for the crank radius, the T stands for the degree, and the W stands for the 2 pi frequency. So we use the formula also to calculate the values. And from the graph, the maximum piston velocity gained from this graph is 0.002871 meter per second at 190 degree, and the minimum piston velocity of 0.002871 meter per second at 406 degree. So next we will see the piston acceleration. The piston acceleration is a measure of how rapidly the speed is changing the function of the crank angle. It can be also expressed function of time if the rotational speed of the engine is set. We can use this formula to find the acceleration of the piston. The same, R stands for the crank radius, T stands for the degree, and W stands for the 2 pi frequency, and the L stands for the continued dot length. So we use the Excel also to form the graph. From the graph, we can get the maximum piston acceleration of 0.000118 meter per second square at 175 degree and 475 degree. Meanwhile, the minimum piston acceleration of the negative 0.000221 meter per second square at 650 degree. Okay, next we see the conclusion. So from completing the assignment, we managed to do our project proposal. Besides learning to calculate the maximum torque, maximum power, and mean effective pressure of our SI engine car model, Proton Perdana, we also learned to calculate the position, velocity, and the acceleration of our car, and for our model's piston. And using the value gained from the calculation, we plot the graph to find out the maximum and minimum value of the piston position, velocity, and the acceleration using the Excel. So I think that's all from me. Thank you.